So, good evening, everyone. This is lecture number 2, and we are dealing with refraction. We'll be specifically dealing with refraction at plane surface. Remember, if you remember in reflection wala chapter for a part, we first dealt with reflection from a plane mirror, then we made the mirrors curved, and that is how we progress. Because to understand reflection or refraction from plane mirrors or plane surfaces is easier. So we always follow that same strategy. Good evening, Surendra. And we first do the plane surfaces and then gradually we move on to the spherical ones. And what was there that we did in the previous class, we studied the laws of reflection and I gave you the vector form of the law of reflection. Do we remember this vector form which is in yellow? Do we remember this? I cross n dot t. Do we understand this? I unit vector cross n unit vector dot with t vector, and I told you that is a scalar triple product, and scalar triple product vanishes or becomes zero when three vectors are in the same plane. Do we understand this? Yes or no? Do we understand this? Is the mic available? Do you understand the yellow thing that I have done here? Scalar triple product. Just need to remember this. This is known as a scalar triple product. And if three vectors are coplanar, that means they lie in the same plane. The scalar triple product becomes zero. Do we understand this?
Yes, sir.
Okay. That was the first law of refraction. And then we had talked about the Snell's law. Do we remember Snell's law? Mu2 by mu1 is sine I by sine R or sine I by sine T, depending on whether I call it R or T. And then we had seen that we can write this Snell's law in different ways. We can write it like this in the yellow one. Mu into V is constant, or I can write it as mu into lambda is constant, or I can write it as mu into sine of I is constant. We all remember this?
Sir,
Yes, beta.
once explain why mu sin I equals constant.
Why?
Mu sin I equals to constant, sir.
Because of
Explain.
Snell's law, beta. Here, mu2 by mu1 is sine I by sine R. You just cross multiply and you get them as constant. Mu2 by mu1. Do you remember this Snell's law? Yes or no?
Yes, sir.
We just cross multiply from here. This goes here and this goes here. So we get mu into sine I is constant. Okay. Just cross multiplication, nothing else.
Okay, sir.
Clear?
Yes, sir.
Just remember it as mu into sine I is constant. That is the easiest way of remembering the Snell's law. I always remember it that way. Mu into sine I is constant. Okay. Rather than remembering mu2 by mu1 is sine I by sine R, I remember it mu into sine I is constant. That is easier for me to remember. Can you do that? Can you do the similar thing? Yes or no?
Yes, sir.
Okay. Now, as I told you that I will also tell you the vector form of this Snell's law. So you can write the vector form of this Snell's law as well. Vector form of this Snell's law. Please write it in the vector form. Again, this vector form is going to only come in JEE Advanced, not in JEE Mains. So you can write it like this. Mu1 multiplied by I unit vector I cross unit vector normal, that will be equal to mu2 times the refracted vector unit vector or transmitted vector cross, and this is how you can write the same Snell's law in the scale in the vector form. Remember here, instead of writing this like this, I should perhaps put a magnitude sign. Magnitude sign is better. I can put this magnitude sign, and this is another way of writing Snell's law. Do we understand this?
Yes, sir.
This is another way of writing Snell's law, or you can write it like this also. Mu multiplied by I cross N. The magnitude is a constant. Now it becomes very good to come in a JEE advanced ka paper. Remember to write it in any of these ways. All of these ways are saying the same thing. Do we understand this, beta? Please raise your hands and let me know.
Yes, sir.
There's different ways of saying the same thing, beta. The more the number of ways you know, the same way might come in the examination hall. And remember, the last ways that I've given you today, they can only come in JEE Advanced. In JEE Advanced, they can only come. So I'll just wait for a minute for you to write down all these things. What happened? The light went away?
Yes, sir.
It's gone.
Power off, sir.
What, beta?
Power cut, sir.
Power cut. Will you be able to see me? Do you see me? Yes,
Yes,
or no?
sir.
Fine, na? It does not
Fine,
affect
fine,
our
sir.
class. It does not affect our class, no?
No, sir.
Okay.
Power आ गया, sir.
Dekha, see, if you keep on doing the good work, power is not going to be a problem. Problem can go and come. Power can go
Your
and
words are so strong, sir.
yes, beta.
Your words are so strong. Sir.
Slow sound. I don't know. What?
Nothing, sir.
Okay, maybe some comment or joke. I did not understand. See, I'm a serious person and I don't get jokes easily. So when you say a joke and you just repeat it once so that I've got a small brain and my brain does not take jokes in the first go. So if you say something funny, please let me know once again, or I might have missed it in the first attempt. Okay, got it? Again, gone. Not a problem. Let us concentrate not on the power cut, but on the problems that we have at hand. And we are dealing with refraction and Snell's law. And this, I think, is a problem from your sheet, from your module, I guess. Find the angle theta A. Theta A. Do you see this theta A? Find the angle theta A. This theta A made by the light ray when it gets refracted from water to air as shown in the figure. Let us first do one or two problems based on the Snell's law. Then I will give you some important notes as well. And then we can move ahead with the topic of discussion in today's class. Everyone, this is, I think, a problem from your module. I think example number 22 or something like that. Problem number 22 or something like that. So you can have a look at this problem if you have the module, I think. So you have to find the angle theta A from what is given in the diagram, and I'll give you a minute, 2 minutes. So this is the next question. We have to find the speed of light in medium A. We know the speed of light in medium B, and we know that the light is passing from medium A to medium B. I'll give you 2 minutes to solve this. Tell me the answer. C into
Root 2 by 9.
root 2 by 9. I think there is something missing there. Maybe you have missed something. Can you try again? Maybe you have missed a small point somewhere here and there.
C root 2 by 9 meter per second.
Not meter per second. I was not talking about. about the unit. I was not talking about the unit. Shall I do it for you, bacha?
Sure.
Yes, bacha.
Root over 2 by 3 into 10 power 8.
Root over 2 by 3. Yes, that looks better. That looks better. Yes, that looks better. Yeah, that I think is the answer.
Root, sure.
Yes,
Root 2 C by 3 root 3.
that is correct. Root 2c by 3 root 3 or root over 2 by 3 into 10 to the power 8. C is 3 into 10 to the power 10. C is 3 into 10 to the power 8 meter per second. So both the answers are correct. Everyone got this? Yes or no? No, yes. How to do it? How to do it is the question, and how will I do it? I only remember it by this mu into A into sine of A. This is the easiest way of remembering it. Mu into B into sine of the angle B. That's it. That is what I apply always, and trust me, I always get my answers. I need to put the value of mu A. Value of mu A is not given. Don't worry. I know the formula for mu A. It is speed of light divided by the speed of light in the medium. Yes or no? I say yes or no.
Yes, sir.
Multiplied by sine of the angle in A, and that is 45 degrees. Yes or no?
Yes, sir.
Yellow, the dirty fellow. So sine of 45, I think sine of 45 is 1 by root 2. So I'll just put 1 by root 2 here. I think I'm not making a mistake. Well, that will be equal to mu B. I don't know mu B, but I know that the speed of light in vacuum in the medium B is C by 3. So mu B becomes C divided by speed of light in that medium, that is C by 3. So I write C by 3. Do we understand this? Yes or no? No, yes.
Yes, sir.
Multiplied by sine of this angle B, which is 60 degrees. What is sine of 60 degrees?
Root 3 by 2.
Root 3 by 2. Well done, my dear friends. Then I can do cut. And I can get the value of VA from here. VA, I will not solve it for you because you have to do this much of job. Root 2C by 3 root 3 is what I will get after cutting short all these things. Do we understand this? Yes or no? No, yes. Can I have raise hand from everyone in the class that we understand this? Student, I hope you got the answer. Everyone in the class got the answer. The other class has gone missing. What that? The camera has gone off, but I hope everyone is there in the class. Everyone has noted this down? Yes or no? Anyone having any doubt? This is the time that you are going to ask me the doubt. Just bacha. Tell me the doubt. If you have any doubt. No, sir?
No doubt, sir.
No doubt, sir. Then can I move on, sir?
Yes, sir.
Then what we'll do, sir, is we'll write some important points about refraction that we may have missed. Important points. Point number 1. If the angle of incidence is 0, the angle of reflection is 0, yes or no? Because angle of incidence and reflection are always same, yes or no? Yes or no?
Yes, sir.
And the angle of refraction, which I am calling it as T. Remember, R for me is reflection and T for me is refraction. Both would be 0 in this case. Do we understand this? I've written R. This R is for reflection. And this T, oops, wrong color. This T is for refraction. Do we understand this, my bacha? Do we understand this? Now, in that case, what will happen? The light will be falling normally. The light would be falling normally. It will actually not bend. Do we understand this? When it goes from the first medium to the second medium, medium 1 to medium 2, incident medium to the refracted medium, it will not bend, but still that phenomena is known as refraction. Do we understand this, bacha? This light is not going to bend. Do you see it is not bending here? Angle of incidence is 0. Angle of incidence is 0. Angle of refraction or T is also 0. It does not bend, but still this phenomena is known as refraction. Do we understand this? Yes or no? Do you understand this? Can I have raised hand that we understand this? Okay, that is the first thing that you should remember, that if the angle of incidence, yes, so then it will retrace. When I say retrace, which is known as the principle of reversibility of light rays, I will give you that. Don't worry, we will write it as well. Incident ray and refracted ray. If your refracted ray becomes your incident ray becomes your refracted ray. That is point number 1 that we must remember. Point number 2. And point number 2 is this one. I hope all of us understand this point. Now, there are 2 things that you have to remember here. What are those 2 things that you have to remember? Why is this coming like this? Now, remember, sometimes you might get confused what happens when light goes from this medium to the other medium, that medium to the other medium. So, how do you remember this? If light moves from denser medium to rarer medium, denser medium means the light is slower. Do we understand this? And rarer medium means the light is traveling faster. Denser medium means mu is more. Rarer medium means mu is less. Is it getting confusing? Are you getting confused? I hope you're not. We understand this, yes or no? We understand this, yes or no?
Yes, sir.
Now remember, mu into sine I is constant. That was our Snell's law. Mu into sine I is constant. That will mean one thing. If your mu is more, your sine I would be less. Yes or no? If your mu is more, your sine I would be less. If your mu is less, your sine I would be more. That means if you move from denser to rarer medium, it will bend away from the normal. I remember it like this: DRA. From denser to rarer, the light moves away from the normal. Do you see it here? Yes or no? This is the incident ray. And the green one is the refracted ray. This hash line is your original direction. And here when you see that it moves from denser medium to the rarer medium, it bends away from the normal. DRA. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now, if it bends, then there is something known as deviation. Do you see this deviation here? Do you see this deviation here? Where do you see this deviation, my dear friends? Look at this angle delta. This angle delta is the angle between, if I just draw it, It is the angle between the original ray and the new ray. Do you see this angle delta? This angle delta is known as the angle of deviation. Do we understand this, bacha?
Yes, sir.
Everyone understands this?
Yes, sir.
Do I need to show you in a bigger diagram? Or you have understood this?
Show in a bigger diagram, sir.
So this is the bigger diagram. I hope you see it now. Do you
Yes,
see
sir.
this deviation?
Yes, sir.
This deviation, this is the angle through which the ray has bent. Original ray was dot dot dot. It has bent away from the normal. The deviation angle is r minus I. Do we understand this?
Yes, sir.
So when it moves from denser to rarer, it bends away from the normal. I have also explained how it bends away from the normal because mu, if mu is less, angle is more. If mu is more, angle is less. Do you understand this? I'll give
Yes,
you
sir.
1 minute to note this down because if you have understood what happens when it moves from denser to rarer, the other part becomes very simple. What will happen when it moves from rarer to denser? From
Bends
denser.
towards normal.
Well done, my dear friends, and that is going to come in the next page. Have you noted this down, bacha?
Done, sir.
Yes, sir.
Then you can write the third part, which I think you can do it on your own. It is on your screen right now. Will you be able to draw this? When light travels from rarer to denser, it will bend towards the normal. So I remember it like this, RDT. Don't have to remember both. You just remember any one of these, DRA. DRA is what I remember from denser to rarer. It moves away from the normal. Yes or no? No, yes. Do we understand this, my dear friends?
Yes,
Yes,
sir.
sir.
Now, can you tell me, my dear friends? Bigger diagram coming up. Bigger diagram coming up. Here, this is the angle of deviation delta. Do we understand this delta? Deviation, deviation, deviation. Deviation is always the angle between the initial direction and the final direction, or the angle between the first ray which is incident and the last ray which is coming out. Do we understand this? What is the deviation here? Can anyone tell me? Fatafat. In the first case, deviation was I minus R.
R plus I.
In the first case, deviation was R minus I.
R
What is
plus
the
I,
deviation?
sir.
Yes, bacha?
R plus I.
Arey, look at the diagram. Yeah, you are math student. Look at the diagram, dear friends. Look at the diagram. Open your eyes. You only see 4% of the universe, but that is worth watching. Open your eyes and tell me.
I minus R.
Yeah, see, you open your eyes and you see the bright new universe. It is I minus R. But here, my dear friends, I is more than R. That is why it is I minus R. In the previous case, R was more than I. Therefore, it was R minus I. Do we understand this? Yes or no? Yes or no?
Yes, sir.
Universe is very beautiful, my dear friends. 4% of which we see 96% of that thing is dark matter. We are still trying to comprehend the dark matter. Do we understand this? Yes or no, bacha?
Yes, sir.
Pakka sir?
Pakka, sir.
Oh, kacha sir. This is a diagram. If you want, you can write it again. Remember, it has been written like the modulus of I minus R. So basically, you just have to subtract I from R. If I is more than R, it is I minus R. If R is more than I, it is R minus I. Do we understand this, bacha?
Yes, sir.
Yes, sir.
Okay, sir. That was the important points about this part, sir. I'll give you a question for homework, sir. All right, sir. So I'll give you a question as homework, and I hope that you try this question. And I guess this question would be in your module. I think from your module only, the module that I got, I think is on the same module. So I will give you this question. And I'll tell you the name of that question number. This is question number, I think 21 from your module, and this is the question that is given to you as homework. Now you can argue, sir, oh, sir, we are only doing refraction at a plane surface, and you are giving me question of refraction at a spherical surface or
Sir,
curved surface. Yes, bacha.
once show previous slide, sir.
One show previous slide. What is has been gone? We can't go back in time, bacha. You are lucky that we. I am more like Doraemon, and I have this time machine that can take you back in time. Remember, whatever has gone is already gone now. Can we move further ahead in life? I asked you that you have done it or not. You said yes, sir. Then I said, okay, move on, sir. Now you say, take us back, sir. How much time do you need in the past? You know, the more you stay in the
Then, sir.
past, the more are there chances that you do something that is going to change your future, and funny things can happen that way. Can you move in the present now?
Yes, sir.
Yes, sir. Then, sir, this sir is the present, sir, and in the present you have a problem, sir, and you are lucky that the problem has not changed, sir, because we have not changed anything in the past so much. So this is the problem that you are going to do, sir, as a homework, sir. This is question number 21 from your module, sir. Everyone has a module, right? Check it. Is it question number 21? Yes or no? Okay, whatever. 2021 के आसपास का होगा. So even if it's not in the module, you can just simply write it. These are the type of questions that are coming in the JEE, and I'll show you the question that the JEE as well. And when I say JEE, I mean JEE Advanced. I don't count JEE Main as an exam.
Sine inverse 1/2.
Hey, we got an answer. Arey, bata. Sine inverse 1/2. Deviation, they are asking, bacha. Deviation, total deviation. When I say total deviation, what it means is, try to understand, you have to find out the angle between the angle between the initial and the final. Which is the initial ray here? I'm not solving it. I'm going to give it an exercise that you will try. Which is the initial ray here? Tell me, bacha. This yellow thing is the initial ray. This initial ray is also known as the incident ray. Do we understand this? Please raise your hands, because we will see this terminology just after now. This first ray is the incident ray. The second ray which has gone inside, and that is known as the refracted ray. Oops. So this gentleman is my refracted ray, and the third ray which has come out. Since it has come out, it is known as the emergent ray. Do we understand this terminology? Incident, refracted, emergent. Yes or no? No, yes? Yes, sir. No, sir. Better I go, sir.
Yes, sir.
So whenever they ask you deviation, my dear friends, which I have total deviation, that means they're asking you the angle between dung, 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 dung. This is your actual direction, dung, 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 dung. And pung, 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 pung. This is your final direction. So they are asking you the angle between the initial and the final direction, my dear friend. Do you understand this? So that is how you have to calculate it. Okay? So I'll give you this as a homework and I will move ahead in life. Can we move ahead in life? Or you want to stay in the past? Past looks good. But we have to move in the present. So have you noted the question? Yes or no?
Yes, sir.
Shall we move ahead?
Sure.
Yes, sir.
Thank you, sir. So here we are in the present, and the present is also beautiful.
Sir, wait a minute.
Wait a minute. Why you always want to live in the past, my dear friends?
Done, sir. Completed.
Done, sir. Completed. That's more like it. Remember, the name of this chapter is ray optics. The other name of this chapter is geometrical optics. Why it is known as geometrical optics? Any idea? No idea. Get idea. Why it is known as geometrical optics? Because this entire chapter is about geometry. Simple things. Radius of the circle, diameter of the circle, angle in a semicircle, laws of reflection, angle of incidence, angle of reflection. This is all about geometry. Simple geometry, 8, 9, 10, not even 8, 9, 10, 6, 7 standard geometry. Simple things. If you remember, you would be doing extremely well in this chapter. Can I move on ahead in life? Yes or no? No, yes.
Yes, sir.
Sure.
That is the next thing. You don't have to note it down exactly. You just have to just read it. Sorry. Principle of reversibility of light ray. I have discussed this before. Yes or no? Remember that concave mirror and that ray of light which was parallel to the concave mirror was passing through the focus. Yes or no? And then I said, if you reverse that light ray, so if the light ray is passing from the focus, it will become parallel. That is nothing but the principle of reversibility of light rays. Do you understand this?
Yes, sir.
So basically, they have just put this in words. A ray traveling along the path of the reflected ray is reflected along the path of the incident ray. Do we understand this first point? Raise hands will give me more
Yes,
confidence.
sir.
Similarly, I do the ulta. A ray is traveling from medium 1 to medium 2. In medium 1, it is incident ray. In medium 2, it is reflected ray. If I reverse it, so it goes from medium 2 to medium 1. Medium 2 wala ray will become incident ray and medium wala 1 ray will become refracted ray. Do we understand this? A refracted ray reverse to travel back along this path will get refracted along the path of the incident ray. So this principle of reversibility of light rays is applicable everywhere. Incident ray, you have an incident ray, so you have a reflected ray. If your reflected ray becomes your incident ray becomes your reflected ray, and vice versa for refraction. Do we understand this? Yes or
Yes,
no?
sir.
No or yes?
Yes, sir.
Well done, sir. So I'll give you a minute if you want to note it down. You can do it now.
Done, sir.
Then, sir, can I move on in life, sir? Then,
Yes, sir.
Pakka na, sir.
Akka, sir.
Arey, I'm having some problems, sir. Here, sir. Just give me a minute, sir. I will just get out of this problem, sir. Just give me a minute, sir. What's wrong here, sir? Just give me a minute. It's got stuck, sir. So what I'll do is I will just go back, sir, and do it again, sir. So what I was saying was the principle of reversibility of light rays, and what we are going to do is the application of what we have done. So we are dealing with refraction at plane surfaces, and the first application of refraction of plane surface is known as lateral shift. Lateral shift when light passes through a glass slab. So that is the heading, my dear friends, that you are going to write. Lateral shift when light passes through a glass slab. Now, what do you mean by this? This is the diagram, and just to make this diagram bigger, my thing just went here and there. So I had to just clarify it. So again, I use the same terminology. This ray is known as which ray? This ray is the incident ray. Do we understand this? Say yes or no, sir.
Yes, sir.
Then, sir, this, sir. This ray, sir.
Refracted ray.
Well done, sir. Refracted ray. Then this ray, sir. Say na, sir.
Emergent ray.
Emergent ray. Well done. This is the emergent ray. Incident ray, refracted ray, and emergent ray. And remember what I have assumed here is I have air on this side. I have some glass slab here. And again on the outer side, I have air. So the ray is traveling from air to air, but in between there is glass. Do you understand this? So medium on one side of the glass slab and medium on the other side where the emergent ray is coming out, both are same. Do we understand this, bacha?
Yes, sir.
I hope you are drawing the diagram. Then in this case, you must understand the first thing, that the emergent ray. Can anyone complete the sentence? Emergent ray. There is a relation between the emergent ray and the parallel ray, which was not in the case when we did the question. The question that was not happening. There was deviation. Here there is no deviation. So the emergent ray which comes out, it is parallel to the incident ray. Do we understand this? Now this will only happen in two cases. Two cases must be fulfilled. The glass slab must be parallel, it should not be curved or in any other shape. And then the medium on one side and the medium on the other side should be same. Do we understand this? Yes or no? No or yes?
Yes, sir.
Pakka na, sir?
Akka, sir.
Okay, sir. So if you have same medium on both the sides and the glass slab is made up of parallel slabs, remember parallel, if the other side is having another angle, this will not happen. So if it is a parallel slab, medium on same side is same, emergent ray will come parallel to the incident ray. This phenomena is known as lateral shift. The deviation in this case, my dear friend, is 0. Do we understand this?
Yes, sir.
Deviation in this case is 0. But this ray gets shifted, and this shifting is known as the lateral shift. Do you see the shifting? See, my dear friends, this is the original direction of the ray. Do we understand this?
Yes, sir.
The new ray which has come out, it is at the same angle, it is parallel, but it has shifted. It has shifted by a length d. This is the length d, and this is known as the lateral shift. Do we understand, my dear friends?
Yes, sir.
This is known as the lateral shift, and the value of this d, the lateral shift, is given by this formula: t times sine of I minus R, t times sine of I minus R divided by cos of R. This is the formula that you must remember. If a question comes on this topic, it would be a straightforward question of what is the lateral shift, and your answer still remains the lateral shift is t times sine of I minus R divided by cos R. What is t here? T here is the thickness of the slab. Do we
Thickness of slab,
understand
sir.
this? Well done. Remember, if the medium is not same on the other side, for example, one side you have air, then you have glass, then you have water, then the emergent ray will not be parallel. It will have some deviation. So there could be a question based on the theory of this thing. There could be a question directly based on the concept. Do we understand this, bacha?
Sir.
Have you noted down the diagram, my dear friends?
No.
Done, sir.
Done, sir. Then, sir, this
No, sir.
Completed, sir.
completed, sir. So there is a
Not completed, sir.
there is a competition going on between one center and the other center. I'll have to be impartial. And I'll wait for a minute for the other students, which I think are boys,
Completed, sir.
to come up.
Not
Boys,
completed, sir.
see, girls are way faster than boys.
Completed, sir.
Completed, sir. Well done, sir. So we come into the present, sir, and in the present, sir, this is the question, sir. Find the lateral shift. This is just a question to make you understand the use of this formula. If you can apply it in the correct way. Find the lateral shift of light when it passes from a glass slab of thickness 10 centimeter. Thickness is given. The angle of incidence in air is 60 degrees and the angle of refraction in glass is 45 degrees. Come on. Again, a competition between this center and the other center. Who gives me the answer faster? And your time, my dear friends, starts now. Yes, my dear friends. Do we
10
have
root
anything?
2 sine 15 degrees.
Yes?
10 root 2 sine 15.
10 root 2 sine 15. That looks like the correct answer. We just need to apply the correct formula. D, the lateral shift, is T times sine of I minus R divided by cos of R. You just have to put the values, my dear friend. T is 10. Sine of I is 60. R is 45. Divided by cos of 45. I think you can do it from here. You can put the values and get the answer, yes or no? And I think you would be getting something of this nature. And that would be your answer. Do we understand this? Can I have some raise hand from everyone in the class that we understand this, sir? And we got the answer. This simple question, my dear friend. And those simple questions are going to come in the examination hall. And when I say examination hall, I don't mean JEE Main, because they are definitely going to come in JEE Main. Talking about JEE Advanced. That is my main concern, that you can do all types of problem. And again, problem with this pasting. Why is that so? Why doesn't shift? What has happened? Okay. Have you noted down this one? I'll have to restart it
Yes,
again.
sir.
Okay. Why I'm having this problem is difficult to understand. But sometimes some things are out of your control and just we just take them in that way. Okay, the next thing, the first thing that we did was known as lateral shift. The next thing that we are going to do is known as normal shift. So there are two types of shifts that you will have to encounter. One is the lateral shift and the other one is the normal shift. And you can see here what is happening here is on one side I have air, the other side I also have air, and then I have a glass whose refractive index is mu. Do we understand this? This glass has a thickness T. This glass has a thickness T. This glass has a thickness T. Now, there is an object placed here at this point. That is the original object. Do we see this? But when I'm watching this object from the other side, this object does not appear exactly where it is. It will appear at a different position, O dash. And remember, it always gets shifted. It always gets shifted in the direction of incident ray. So that is the first point that you must remember. The object gets shifted in which direction? In the direction of incident ray. Do we understand this?
Yes, sir.
The object will always get shifted in the direction of incident light. As you can see, this X is the shift and this X is known as the normal shift. Do we understand this? How it comes does not matter. What matters is that you know how much it has shifted, and the amount it has shifted, X, is given by this formula, T multiplied by 1 minus 1 by mu. What is T here? What is T here?
Thickness.
T is the thickness of the glass slab. And remember, this formula that we have written is valid only if the medium is surrounded by what thing? It is surrounded by air. It is surrounded by what? It is surrounded by air. Remember, in refraction, we may have other mediums also coming. Now, the second formula that I'm going to give is what will happen if it is surrounded by some other medium which is not air. In that case, your X becomes T into 1 minus 1 by mu R. What is this mu R, my dear friends? What is this mu R, my dear friends? Anyone who tells me what is this mu R?
Relative refractive index.
Relative refractive index of what? Relative refractive index of what? This is the formula when it is kept in a medium which is not air. And here, my dear friends, this mu R is the refractive index of glass with respect to the medium. Do we understand this, my dear friends?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Do you understand the difference between the yellow formula and the green formula? Do we understand the difference?
Sir.
Yes or no? No or yes?
Yes, sir.
Have you noted down the formula, sir? Have you noted down the formula, sir?
Done, sir.
Can I move forward in life, sir?
Yes, sir.
Now I'll give you a small task. What will happen, my dear friends, if instead of one glass slab, you have multiple glass slabs? Let us say you have n number of glass slabs like this. The first glass slab having refractive index of mu1, the second glass slab having refractive index of mu2, the third glass slab having refractive index of mu3, thickness T1, thickness T2, thickness T3. What will be the shift if I put an object here? If I put an object here and if I watch it from the last side, what will be the shift? What will be the shift? Any idea, my dear friends? What will be the shift? Any idea, my dear friends? What will be the shift? Do you understand the question, beta? I will give you this as a home task. Do you understand the question? Do you understand the question, bacha? If I have more than two or three n number of slabs, and I always do this question in the class and I give it for students because this is the time when this question comes, when this concept comes, and I give them as homework to find out this. What will be the total deviation? Can you do that for me, bacha? Yes or no? Yes, sir. This is yes, sir. This is no, sir. Sir, we can't do this, sir. Yes, sir. Because if you can do this, beta, then we will be solving this problem. And as you can see, the problem is very long. And do you remember? Do you know which year this problem has come, my dear friends? This one, this one, this one. This one. Which year this problem has come in which paper? Yes or no? No, yes. Any idea? No idea. Good idea. This question came in this year's JEE Advanced. And if you remember simple things correctly, look, it looks like a big question, but can be solved in this much of space. This much. But to do that, you have to be smart. And you have to do your task correctly. Because even if I tell you everything in this universe, if you don't practice with your own hands, nothing would be of any use. You must have heard the story of Drone and Arjun. Arjun was his famous disciple. Karna was not. Eklav was definitely not. Ashwathama was the dear son of Guru Drone. Now, Guru Drone had all sorts of weaponry in his reporter, and he obviously gave Arjuna the Brahmastra because he wanted Arjun to use it. He knew that Arjun could use it. Arjun was the only worthy one. Maybe Karna was also the worthy one to use that Brahmastra. He gave that Brahmastra and he knew that Arjun would be able to use it. He also gave that Brahmastra to Ashwathama just because of the love of giving it to his favorite child, his son. And he used it in the most disgusting way to kill a child which was still unborn. So, out of love, I cannot tell you everything because I know that you might not be able to use it. You have to gain the confidence that if I tell you something, you can use it. Then only I am going to tell you that thing. Otherwise, I will just move ahead. Do you understand the moral of the story? Drudron, Arjun, Ashwathama, do you understand this? So you'll have to do your task. Then only you are going to utilize that weapon that I am giving you to the best possible use. Having said that, this is the end for this class. And we have taken some really good strides in this class. We have moved ahead with our course curriculum. I'll see you in the next lecture. And I hope that
Bye, sir.
you can tell me the answer of the question that I gave you. Yes or no?
Yes, sir.
Okay then.
Bye, sir.
I will see you in the next class. Take care and have a nice day, beta.